It's a great honor and pleasure to stand in front of all of you in this august audience to talk about a very, very important and great mission which was accomplished very recently this year along with JPL NASA, the NASA ISRO Synthetic Aperture Radar dual frequency single purpose satellite, which was successfully launched from India on July 30th, 2025. Now let us just have a look of the presentation overview. This is my presentation overview. I will give you overall mission overview, launch performance, unique features, and the joint responsibility of NASA, JPL, and Indian Space Research Organization, and where we stand today and what are all the major applications. Then my co-speaker is going to talk about a little bit about the performance. In fact, I want to tell this satellite is realized jointly by NASA, JPL team, NASA and ISRO. First of all, let me congratulate the JPL NASA team for their outstanding work, whatever they have done, and also the ISRO team for their outstanding activities. Now, if you look at the mission overview, it is the two payloads, a L-band SAR payload and S-band SAR payload. L-band SAR payload is realized by JPL NASA. It's a very, very unique payload. And again, S-band SAR payload is realized by Space Applications Center of Indian Space Research Organization. And together, we have built the satellite. The satellite is built by Indian Space Research Organization, and the launch vehicle also is from ISRO. And this is the first mission by our GSLV vehicle to the Sun synchronous polar orbit. And the satellite altitude is 747 kilometers and 98.4 degrees the inclination. The targeted lifetime is 5 years mission life. But then we are sure the lifetime is going to exceed at least 50% more than this, and it has got a 240 kilometer swath with 5 to 1000 meters resolution, and launched by the Indian launcher, the GSLV, and the capability of the launcher is given. The LEO capability 6,000 kg and liftoff mass of the vehicle is 4,200 tons. And the launcher performance, you can see this was the 18th mission of GSLV. It has got 4 liquid strap-ons and a core solid motor, and second stage is again a liquid air-storable liquid stage, and upper stage is a indigenously developed cryogenic stage with something around 15-ton equivalent propellant loading with a liquid oxygen, liquid hydrogen system. And this is our 102nd launch. In fact, I also want to tell this August audience, we had the successful launch of 100th launcher from Indian soil on 29th January. And that was again yet another GSLV vehicle, and this was the 102nd launch and the first GSLV mission to, as I told, to the Sun synchronous orbit. And in fact, all the propulsion system and the entire vehicle system performed as expected and as predicted. And you can see the performance of the solid motor, all the system. I think you are seeing the graphs. And the vehicle injected the spacecraft precisely in the orbit. 742.9 into 745.6 is the nominal orbit, what was expected with a dispersion of up to plus minus 20 kilometers can be injected, but then it injected with just 2 kilometer, 2.5 kilometer within that dispersion it injected. And the unique features of this mission, it's a first of its kind, dual frequency radar imaging mission in L-band and S-band using advanced SweepSAR technique. And L and S-band space-bound SAR data with high repeat cycle, with high resolution. In fact, every 12 days, the Earth can be covered. Revisit time is 12 days. And high resolution, larger swath with capability of full polarimetric and interferometric modes. And large size. And it is thanks to, again, JPL, it is a fantastic unfurlable antenna, 12-meter antenna, which was realized and deployed in the space. And again, important thing is a free and open data policy for this mission. And now if you look at, this gives the overall picture and responsibility. NASA JPL is responsible for L-band SAR payload and 12-meter unfurlable antenna. It's a very, very unique payload and fantastic activity they have done. Let us give a big hand to JPL NASA team for this outstanding work, whatever they have done, realizing the payload and unfurlable antenna. And of course, the ISRO realized the S-band payload and entire satellite mainframe system. And of course, the launcher was realized and launched by ISRO. I think you are seeing all the photographs. And coming to the spacecraft overview, it is a almost 2,400 kg satellite. The dimensions are given here, something around 14 meter by 14 meter by 13.2 meter. That is the type of thing. And we had a monopropulsion system, and power is something around 70 volt regulated power supply. And we had data handling and storage and flash drive storage system. Communication system is S-band, TTC, and K-band data download link. And then coming to the mission phases, of course, the launch was done on 30th July. It was a historical day for India because of the international collaboration, that too with a great partner, JPL NASA team. And the entire satellite was realized almost 10 years time frame. It had taken a lot of time, but then it was done a very systematic, meticulous, outstanding work was done, and the payloads were realized. In fact, from the conceiving stage onwards, it had to start defining the mission requirements, and both the teams working together, and yet demonstrated a teamwork. That's what I am so happy. More than the payload or the satellite, it was a teamwork exhibited together, JPL and NASA team and ISRO team. And of course, in the past, we have worked with a lot of partners, but it is yet another important demonstration of a teamwork. And the initial phase was done. I think you are seeing the pictures. In fact, antenna was deployed on August 15th. And the antenna deployment, please understand one thing, the antenna was deployed before mounting with the satellite. It was deployed in USA, and the experiment was done. And after mounting in the satellite, you know, it is a single point failure, you all will agree with me. And it was a very, very exciting day when the antenna was perfectly deployed on 15th August. It was exciting day. Always, also, I think the JPL director also told it was also a tensed moment because anything happens, then you know. And it is a costly satellite realized spending lot of money. And of course, I am not going to talk today about the performance of the payloads because right now the calibration is going on. In fact, we have got the first pictures from both S-band SAR payload and L-band SAR payload. We have got the first pictures. And from our side, we are going through the calibration process. And maybe in another 1.5 months, 6 weeks, entire calibration will be done. And we are going to declare the satellite is fully operational. That is the place we stand. And coming to the spacecraft realization phase, I want to show a couple of photographs. What you are seeing is the structure with the propulsion system. And of course, the equipment bay closer and payload autonomous testing picture, then payload assembly with the spacecraft, and then catch-up test. That is yet another important test what we have to do because of 2 SAR payload, then polarity test. All the tests was very meticulously done and gone through. Then of course it's a solar panel deployment test. And then we are having solar panel illumination test and thermovac test. Thermovac test is, you all know, I think I need not explain to this August audience the importance of that. But I want to tell all the tests went through very well and without any major observations, and that was giving a great confidence and satisfaction for going on with the launch program. Then, of course, the entire satellite, after completely realizing the payload came from USA, then the entire satellite and one payload came from Ahmedabad. The entire thing was built in Bangalore in India. And after completing all the tests, the satellite was moved to the launch pad area. There we carried out the necessary required test program. Then, of course, it was moved to the launcher and it was assembled. And I think let us have a look of this video, which gives a glimpse.
The NISAR satellite was successfully launched from the spaceport of India SDSC, SAR, Sriharikota, aboard ISRO's GSLV F-16 launch vehicle on July 30th, 2025. NASA ISRO Synthetic Aperture Radar, NISAR, has traversed a long journey in time across the globe since its conception in the year 2014. The project has been a testimony for great partnership between ISRO and NASA, which has fructified into the mission of NISAR. It was the first Earth observation satellite with dual-band SAR onboard, a L-band system with wavelength of 25 centimeters, and S-band system with wavelength of 10 centimeters. The NISAR observatory has three major components: the satellite bus system developed by URSC ISRO Bengaluru, the boom reflector system developed by JPL, and the integrated radar instrument structure, jointly developed by JPL, SAC, ISRO, Ahmedabad. The work shared between the two organizations, ISRO and NASA, aided the realization of this complex mission. Towards realization of integrated radar instrument structure, IRIS, JPL realized the radar instrument structure and sent it across SAC, ISRO, for assembly of S-band SAR. The S-band SAR, designed, developed, and realized by AEST ISRO, was integrated, tested, and sent back to JPL. L-band SAR and other engineering packages, along with the boom and the reflector, were parallelly developed by JPL. URSC ISRO designed and developed the data handling package to interface with S-band SAR. Checkout team from URSC ISRO carried out tests with checkout system deployed at JPL to acquire data, process, and clear the system for next phase. Even when the world faced the challenge of global pandemic COVID-19, ISRO team continued at JPL without stalling the project. On the other side of the world at Bengaluru, realization of spacecraft elements was being carried with Vega. The new cleanroom in AIT-1 extension was getting ready and received its first occupant, NISAR. The twin checkout rooms, cleanroom, sitting places, office rooms, and the conference hall were all made ready to support NISAR integration and checkout activities. In March 2023, the integrated radar structure took off from the US and landed on the Indian soil in a large US military-owned C-17 aircraft. Spacecraft mainframe underwent disassembled mode of testing, after which panels were closed. An iris was integrated with the spacecraft, where it was evaluated for performance of radars, K-band downlinks, S-band TTC characterization, and also auto-compatibility with all element in the radiating mode. Both ISRO and JPL teams supported 24/7 shifts, collected enormous amount of data for confirming the thermal behavior of the various elements in the satellite. In view of the anticipated thermal glitches, the reflector had to undergo a thermal treatment, as it was feasible to carry out only at the source. The reflector was shipped back to US in the month of March 2024. The reflector underwent all the required rework, post-rework deployment test at Vandar site, and was shipped back to India in October 2024. The reflector was reintegrated with satellite at URSC ISRO and tested and shipped to the spaceport of India SDSC SAR. This GSLV F-16 mission marked the 18th flight of the GSLV, the 12th flight to be equipped with an indigenous cryogenic stage, and the 9th operational flight using this stage. Uniquely, it also became the first ever GSLV mission launched into a sun-synchronous polar orbit. On July 30th, 2025, NISAR was successfully launched.
GSLV F-16 vehicle has successfully and precisely injected the NASA ISRO Synthetic Aperture Radar satellite, NISAR satellite, into its intended orbit. Let me congratulate all the teams from ISRO and NASA JPL on this outstanding success.
This Earth science mission is one of a kind and really shows the world what our two nations can do. But more so than that, it really is a pathfinder for the relationship building that we see across our two nations, across India, the United States, building upon decades of collaborations that already existed.
Currently, NISAR is orbiting and studying the Earth with new eyes and will meet the needs of the global scientific community.
Yeah, so it has got a lot of science applications. I think I'm not going to dwell. And you are seeing the slide, the host and ocean, and the earth observation, hydrology and soil moisture measurement, solid earth deformation studies, forest above ground biomass, forest disturbance, mangrove types of cover, land intonation extent, surface soil moisture, snow water equivalent, land ice velocity, sea ice type motion, and high resolution ocean surface wind. I think all these applications, all the earth observation applications are there. And then, of course, science outreach, we are expecting huge thing. Already, we had conducted enough meetings, and all the people are given enough training how to do, how to utilize the data, everything is given. And in fact, before I hand over to the JPL team for the presentation, I would like to once again reiterate, it is yet another demonstration of a teamwork jointly by JPL, NASA, and Indian Space Program. It was a fantastic program. The satellite successfully realized, successfully launched. The satellite is fully healthy right now. Right now, the payload calibrations are going on. Now, let me hand over to Madam for her presentation. Thank you.
Thank you very much, Dr. Narayanan, for this very comprehensive overview. And it's now a pleasure to hear NASA's take on this mission. So, Dr. Saint-Germain, please, the floor is yours.
Thank you so much. Thank you. It is a thrill to be here with you all today. My name is Karen Saint-Germain. I'm the Director of Earth Science for NASA. And I thought I would start in the very beginning because we are just almost exactly 11 years from today, 11 years ago today, that we signed the agreement that initiated the NISAR project right here at the IAC. So it's a special thrill to be back here showing you the successful launch and deployment, and now I will get to share with you some of the very first science results coming out of the mission. But first, and we just saw a lovely video, so I won't dwell here, but this is the first partnership of this magnitude between our two nations, and it's a unique radar system in a couple of ways, and I'll highlight those to you as we go along. So we had a very successful launch. I will say there were 2 days in this mission that were real nail biters for me. The first was launch day. It's always a great day, and you're holding your breath until you see that you've had clean separation and power positive. The second was the day that we unfurled the antenna. We've talked about this deployable antenna, but to see it happen, when the antenna is stowed for launch, it's like an umbrella. It's all bundled up, and it's about 1 meter in diameter. And then through multiple stages, the bundling gets released, and it springs out with stored energy to 12 meters, and then slowly gets tensioned out to the full 40-meter diameter. And that's what you see depicted in the lower right here. So that happened in August, and what followed is the very first images. So this is one of the first images from the L-band SAR that we released. This happens to be taken over Mount Desert Island, which is an island off the coast of Maine. Maine is the northeastern state, the most northeastern state of the United States. So in that lower left panel, you see the entire NISAR swath, and you can see a little yellow rectangle. The image in the background is the zoom out of that what's in that little yellow rectangle. So it gives you a sense. The swath itself is 240 kilometers wide. But when you zoom in, you're seeing spatial resolution that is on the order of 5 meters. So extraordinary. You're seeing purples and greens here. This is a false color image, of course. And the greens represent forested areas generally. This is a very rocky part of the country. The purples indicate bare exposed rock. And in the upper right, you see the village of Bar Harbor. So the purples are representing hard surfaces, bare rock, or built environments in this first image. Second image that we released, so what you're looking at here is a region in North Dakota. This is in the central part of the United States, one of our northern states. And in the upper panel, just for comparison, is a visual image. So the upper panel is the kind of image that you're used to seeing. The lower panel is the first radar reflectivity image. And you see immediately that features pop out in the radar image that weren't visible in the optical imagery. So now I'm going to zoom in on what exactly are we seeing in that SAR reflectivity image. First thing you notice is, of course, you're seeing a lot of geometry. That indicates managed fields. And you see some fields indicated there in the very bright colors are cornfields. So you're seeing vegetation that has structure and it's tall. You also see in the lower left soy fields, has structure, vegetation, but it's shorter vegetation. So we're seeing, even in just the reflectivity, different types of vegetation. You can also see in there's a river meandering through, and you can see the wetlands and forests growing immediately around that vegetation. And of course, the circular shapes indicate center pivot irrigation. So this is a radar backscatter image. So this is the kind of image we normally see out of radar. I'll show you one more. We just got this one in this morning. This is an image taken in Australia, and I think I may not pronounce this exactly right. I think it's the Yathong Nature Reserve. And what you're seeing here is a lot of green. That's a lot of vegetation and some farmland down in the lower right. So these are the normal kinds of backscatter images. What's really exciting about NISAR is that when we are fully calibrated, we will be able to see change. And that's indicated here in our very first interferogram coming out of the L-band NISAR instrument. So the way we create one of these interferograms is we're really looking at the difference over the same location between one overpass and the next one. These happen to be overpasses that were 2 days apart, and what you're seeing in the center with the interferogram represents change. Now, in this case, we aren't fully calibrated yet, and actually the first image was taken when the instrument was at a lower altitude than the second. So you're seeing change that is has a combination of contributions. One being the difference in the atmospheric path between the first path and the first overpass and the second, mixed in with any changes that occurred on the surface. But what we're so excited about is this is an interferogram coming almost right out of the box. So this demonstrates the phase stability of the radar that is going to give us that very precise imagery of change in the surface of the Earth. This will see change on the order of a centimeter or so. The image on the left is just the uncalibrated backscatter. The image on the right is the correlation, which in the darkest areas are 0 correlation, and as it gets brighter, you're approaching a correlation of 1. But the real showstopper is the image in the middle. I should have said, in these images, you're seeing these black stripes. Those won't be there when we are in full scientific mode. What you're looking at there is the period where we have to turn off the receiver when we're transmitting the pulse, right? So we'll make those corrections as we proceed toward full operations. And of course, we are looking at changes in the surface of the Earth. Some of those will be vegetation and things right on the surface, but we will also be changes and we will also see changes in the surface of the Earth that are reflections of changes that are happening underneath the surface. All of this is going to give us a better understanding of how the Earth works, in other words, discovery, and I'll talk in just a moment about the kinds of applications or use of the data. But these techniques, the technology and the techniques that we're advancing here, can also be used in other pursuits when we're exploring other planets. And I know all of you here heard a lot about the Artemis program earlier this week, and we're very excited about that as well. So we always see the study of Earth as just the other side of the coin from our exploration priorities as well. Dr. Narayan talked a little bit about the applications. I just want to emphasize that here, that we're talking about discovery and learning about what's happening on the surface and under the surface of the Earth. But also, we have 180 organizations around the world that have been working with practice data and are ready to go as soon as this data, the NISAR data, are available and fully calibrated. And they will be using the data in a wide variety of ways. So discovery and action, that's what NISAR is about. Enabling smarter decisions where people need to make them, when they need to make them around the world in a wide variety of applications. And to access the data, so we are at about day 60 of 90 in this first phase where we are calibrating and activating the system. So in just about a month, in November, the data will all be openly available. The L-band data will be available through the Alaska SAR facility. The link in the middle is where you can go to find that. And then through our approach, our open science approach, you can also go to that second HRL to download the software and process the information yourself. But fasten your seatbelt, because this mission is going to produce 80 terabytes of data per day, and that's for quite some number of years. So this mission will double the entirety of our holdings of Earth science data at NASA that we've collected for 60 years. So we're thrilled. We're thrilled with the partnership. It has been, I agree with you, an absolutely outstanding partnership, working through real challenges, some imposed on us by COVID, some were the normal technical challenges along the way. We worked through them all, and I couldn't be happier about being here to share with you this first look at the promise of the NISAR mission today. Thank you.
Thank you so much for presenting this amazing, interesting mission. And please follow up, of course, on all the results that will still follow. Please join me in giving a very strong round of applause to the two speakers of this late-breaking news session. Thank you very much. We're unfortunately running out of time. We don't have time for questions now, because I need to introduce already the second late-breaking news session. So once again, thank you very much for being here and presenting NISAR.
Thank you. Oh,
Ah.
photo, okay.
Oh.